for each of these. Again, we're going to graph each of these and then write out what the period's going to be. So now for A, now we've got y equals cos x. We know what our cos graph looks like. Our parent graph looks like that. What does that 6 do? Multiplies our x value by 1/6. So it's going to compress it horizontally. As far as being able to draw that out quickly, we're going to do the following. First of all, we're going to know that's not going to affect our maximum or our minimum or our amplitude. It's still going to go from 1 to 1 if you squish it like an accordion. But normally, right here, one period was 2 pi. If you're going to squish that by 1/6, what's that point going to be now? Pi over 3. And we could start by writing it as 2 pi over 6. Does that make sense? Because we've just multiplied our 2 pi by 1/6. And again, you can leave it like that, or you could simplify it to be pi over 3. Now, every time we graph it, we will split it up into 4 equal sections. So as far as labeling things go, if we know that one full period is 2 pi over 6, if we cut that in half, what are we going to get? Pi over 6. Half of 2 pi over 6 would be pi over 6. And half of pi over 6 will be pi over 12. For figuring this third one out, once we've split it in half and split it in half again, you now know that this distance is 1 pi over 12. 1 pi over 12, 2 pi over 12. This will be 3 pi over 12, which you could simplify to pi over 4. But as far as counting things go, isn't it easy just to count 1, 2, 3 pi over 12 and label it that way? So now we've separated our 4 sections into the new 4 sections after it's been compressed. Our cos graph still starts at a maximum and then goes to the middle, down to a minimum, back to the middle, and back to a maximum again. And we can draw the shape with the new period. And we can now answer the question. Period is 2 pi over 6 or pi over 3. No, you could leave it as 2 pi over 6. That would be fine. So for part B, graphing this, what is that 2/3 going to do? We're going to multiply our x values by 3 over 2. As far as graphing this, we know that our tangent graph look like a bunch of x cubed graphs with asymptotes at certain places. The key to graphing this one, when you're going to squish it or stretch it horizontally, is knowing where these asymptotes are. And the first one is at pi over 2, negative pi over 2, and 3 pi over 2. Basically, your asymptotes on your unit circle are where tangent is not possible. So when I multiply the x values by 3/2, where are they going to be now? So we're going to multiply them by 3 over 2, 3 pi over 4, negative 3 pi over 4, and if we did one more, we would have, whoa, that's not a very good looking 4, is it? 9 pi over 4. The shape of our graph is still going to be the same. Our period was pi, and now our period is, well, we've multiplied by 3 over 2. So our period is now pi times 3 over 2, 3 pi over 2. And sometimes people actually count, well, from here to here and here to here, that's 3 pi over 4 plus 3 pi over 4. That's going to be 6 pi over 4, which reduces to 3 pi over 2. As far as figuring out that period, how long it takes to repeat itself. So for the tan graph, what you're going to do as a starting point is you're going to start with your asymptotes. And you're going to figure out where your asymptotes are going to be. And then you can draw the same shape that you had from before. So now for sine of x over 7, again, we know what our sine graph looks like. We're going to draw this one. Again, we're going to split it into 4 equal sections. But our period was 2 pi. What does that over 7 do? It's going to stretch it horizontally. We're going to multiply x by 7. So instead of having 2 pi here, it's going to be 14 pi. And half of that, 7 pi. And half of that, 7 pi over 2, or 3.5 pi. 1 7 pi over 2, 2 7 pi over 2s, 3 7 pi over 2s. 3 times 7 is 21. 21 pi over 2 will be your third. Where does sine start? It starts on your center line, in your middle, goes to your maximum, down to your middle, down to your minimum, back to the middle. And now we can answer what our period is. Our period is going to equal 14 pi. Now to summarize, and this is at the bottom of your page, for sine and cos, what we're going to say is we're going to say that if you have a number multiplied by x inside either sine or cos, and we use the variable capital B for that because if there was a number out in front, we're going to use capital A later on for that. And since the next number will happen in front of the x, then it was B. Then any horizontal shift will be C. Any vertical shift, we're going to use the letter. You were close. You were close to F, which is fail. Yes, D. Anyways, but if we had a number in front of the x for sine and cos, it would be B. And what that does is that affects our period. So we have two formulas that we can write. We can say, well, our period is going to equal, does this make sense? Well, it started with 2 pi, but if B was 2, then we would be multiplying everything by 1 over 2. If B is 3, we'd be multiplying by 1 over 3. So whatever B is, you're going to be multiplying by 1 over B, which is the same as dividing by B. So our period is going to become 2 pi over B. Let's see if it worked in our previous example. Our B value was 1/7. What happens if I take 2 pi and divide it by 1/7? Well, dividing by a fraction, the same as multiplying by the reciprocal. So you'd have 2 pi times 7/1, which equals 14 pi, which is what we found out. So for sine and cos, whenever you have a b value, your period becomes 2 pi over b. What is it going to be? And so this is a formula. It's not on your formula sheet, but some people like to memorize, although you don't really need to memorize it because if you know how horizontal stretches and compressions work, it just happens naturally. If you rearrange this formula, you find out that the b value in your equation is always 2 pi divided by the period of the function. Because sometimes you're going to be given a question like, here's the graph, what's the equation? So the fact that you know that the period is 14 pi, if you plug that into here, you'd figure out that b is 1/7. And then you'd be able to write your equation that it has to equal sine of x over 7 or sine 1/7 x. What's going to happen for tan? When you're multiplying inside tan, well, what's the period normally for tan? Pi. So the formula for tan is just going to be pi over b. Or rearranging this, that your b value is always pi divided by your period. Did I give you questions for this one? 3, C, and D.